In most computer programming languages, there are variables and then types of variables. However, R views everything as an object, which belongs to a class. So more simply, objects are variables and the class is their type. So in some programming languages, you have to explicitly declare the class in which the objects belong. However, in R, it's automatically defined by the value assigned to the object. So the value assignment is made with the operator, or as we've previously called it, the gets operation. And there are 5 basic types of classes, or more specifically in the R language, we call them atomic object classes. And those 5 atomic object classes are character, numeric, integer, complex, and logicals. So let's say I want to assign the term clarinet to an object and call the object X. I can write X gets, and because it's a word, I'm going to put it in quotations, clarinet. I'll hit return, so we take a look up in the global environment, and we can also call this our workspace. So in our workspace, the value X is assigned the term clarinet. Now, in order to check the class of object, what we could do is use the function called class. And as an argument, I can put the object name. So I'll type the function class, and then in parentheses, we assigned it X. So I will just write X, I'll hit return, and it comes out as a character variable. So let's say I want to assign pi, or the number 3.14, to an object, and I'll call the object pi. I'll type pi gets 3.14. I'll hit return. So now the value 3.14 is assigned to the object called pi. And now let's say I want to check the class of what pi is. So I'll run the function class, and then I can type pi for the argument. So I'll hit return. And then that comes back as a numeric class. So in R, we can see words which are also called strings, or strings of letters, is a character variable. Any decimal number is going to be considered a numeric. Now let's say I want to assign an integer or whole number, 15, and I want to assign that to the object called Z. So I can type Z gets 15. Now, if I type return and assign it to Z, and then I check the class, you notice that it's going to come back as a numeric. So if I type in a whole number, R is automatically going to consider it a numeric as it has decimal points, 0.0000 to infinity. If I explicitly want to make this an integer, what I have to do is use the letter L after the number. So what I can do is take Z again, and I can type 15, and I'll type the letter L after. I'll hit return. So now it's going to override Z and turn 15 into 15L. Now, if I check the class, it comes back as an integer variable. Now, the 4th type of atomic object class is complex. It's a little bit beyond the scope of what we're going to be doing here, but a complex number in mathematics is a pure imaginary number. So as an example, let's say I want to assign an imaginary number to the object C. So I'll say C gets, and then we can say 5 plus 2i. Now we can check the class of C, and it comes back as a complex number. Now the last type is a logical, or sometimes these are called booleans. So a boolean or a logical can be either true or false. So let's say I want to assign true to the object T. I can say T gets true, and then I can check the class of T, and it comes back as a logical. Same thing. Let's say I want to assign the boolean false to the object S. I can say S is false, and then I can check the class of S, and it comes back as a logical. These are really important considerations for the type of data we're going to be working with, because it's not only going to dictate the type of statistical analyses we run, but it's also going to dictate the basic type of structures of the object classes that we're going to work with in R.